So we've talked about measurement and where it came from. They started using parts of their body like their thumb and their foot and so on to measure. And we talked about what a big change it was when things were standardized. How when King Edward was one of the ones that did it, said, his thumb was going to be the official inch and his foot, the official foot, and so on. And so when they cut something to represent that, they held it next to his foot and they cut it to that length and they passed them out for everyone to use. How that changed measurement. And that's actually a huge step. Even though it sounded like a very self-important move, it was a huge step in measurement. And we discussed in the last unit how that allowed us to take a foot and use it for stuff that was more versatile. Rather than just measuring things along the ground with a foot, we can now measure the height of this wall, because I didn't have to get my foot up there to measure it. I could take that piece of wood or whatever it was that was cut to King Edward's size and use that to measure it. Well, the next development that came in measurement was a big one. Let's say I go to measure the length of something, and I'm using that block that was cut to the size of King Edward's thumb to make an inch. So I'm going to measure that length. I've got to sit there and I've got to take it and I've got to move it. Now this one wasn't hard to do the first move because I had the shadow of it there before. So there's 2 inches. I go to move it again though, and I've got to get it exactly where the last one ended. 3, 4, and you can see every time I move it, there's a chance for a little bit of error in getting it moved to exactly where it ended before. Now imagine if that's your thumb and you're moving your thumb along there, just how hard it is to get the point of that knuckle exactly where the tip of your thumb was before. So what happened, and this was more for expediency than it was for precision, was somebody came up with the idea, let's just take a stick or whatever and take that block that we have of King Edward's thumb and just mark out on it. There's one, and now when I move it to mark the next one, I've got a mark to put the end of it on. And then there's 2 and 3 and so on. And this is really the beginning, the first measuring device, the first ruler. So now when I went to measure the length of something in whatever units happen to be used here, let's say this is inches, we would put the end of this stick, the end of the ruler, at one end of the object and see where the other end ended up. So this blue object here would be measured, if we were using this ruler, would be measured at 3 inches, because that is the nearest division. Now you might say, well, it's close to halfway. Can't we call it 3.5? Well, technically, no. You should round it to whatever the nearest division of that ruler is, because if we call it 3.5, we're making a statement about the ruler, and we're going to get into that in just a minute. Let's say we want to measure another object that looks like this. What's that one going to be measured at using this ruler? Well, it's still at 3 inches. Are they the same length? Not quite. They're close, but not quite. This is a concept called precision. This ruler is not precise enough to distinguish between these 2 objects. And that's what the definition of precision is the ability to distinguish between 2 similar objects. So this ruler here is not down to that degree of precision. How do we increase its precision? Well, the first thing that they did was this. They just cut each division in half. Pretend they got those in the middle. So now it's measured to the nearest ½ inch. Well, both of those, both the blue and the red, are still closest to 3.5. So this still is not precise enough to distinguish between them. So what would be the next step? Cut each of those in halves to make quarters. Now, if you look at that closely enough, it appears that the blue one is closer to the 3.5 and the red one's closer to the 3.25. It's now precise enough to distinguish between those 2 objects. Question for you, if anybody can think of why. Why would they divide their inches up into halves, quarters, eighths, sixteenths, like what we see on our tape measure, instead of doing something simpler like tenths, well, it was just a matter of technology. Let's say this is my inch. Yes, I know it's a little bit big. But if I want to cut it in half, all I have to do is that. It was easy to cut things in half. You just fold them. Force, fold it again. It's in force. So that's why we ended up with fourths, eighths, sixteenths, and so on, was that's all they had to do. Fold it in half. Cut the unit they were using in half. To cut something into 5 equal pieces or 10 equal pieces was a lot tougher. And with the technology they had, it wasn't, I mean, they could use some, they had geometric constructs that would do it, but it was just simpler. So now looking at this ruler, the precision, or what we actually refer to as the degree of precision, describes its ability to distinguish between similar objects, as we mentioned. The degree of precision of a ruler is equal to its smallest division. So on this ruler, what is its degree of precision? Somebody said it. A 1/4 inch. This ruler has a degree of precision of a 1/4 inch. The smallest division is a 1/4 inch. Now you'll notice with both of these, the red bar and the blue bar, neither one of them were exactly on their measurement. The blue bar is not at exactly 3.5 inches. In fact, anything from here to about here would be called 3.5 inches using this ruler, wouldn't it? How far away from the 1/2 inch mark could that be and still be called 1/2 inch? 1/8. There you go. And that is the possible error in a measuring device. Now, I'm not talking about the possible error in the measurement, because there's human error that goes into that too. If we screw up and don't line this up perfectly, that's a different type of error. I'm just talking about the error in the device. Is equal to 1/2 of the degree of precision. And we said in this case, that's 1/8 of an inch. So you take 1/4 times 1/2 or divided by 2, either way, you get 1/8. So let's take a ruler here. Pretend my artwork is not terrible. And just focusing on that little section between 2 and 3, what is the degree of precision here? Assume this is in inches again. Well, how do we figure out what each of those divisions comes to? Well, we count. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that means each division is a 16th. Perfect. So the degree of precision is the 16th. Now, to be honest, I usually cheat a little bit. Most rulers have an easy to spot 1/2 point. So I'll take it to the 1/2 point. And if there's a lot of divisions, I might even take it down to a 1/4 point and count 1, 2, 3, 4 times 4 would be 16 in the whole inch. So that's 16ths. So there are ways to shorten it up so you don't have to count the whole thing. So degree of precision of a 16th. What is my possible error? My built-in error. What's that? Well, it's a 16th times 1/2 or divided by 2, which is going to be 1/32 of an inch. 1/2 of the degree of precision. So let's say that using this ruler, I have an object that is reported to have a measurement of 2 3/8 inches. We know it's not exactly, most likely not exactly 2 3/8 inches. that it was just closest to the 3/8 mark on the ruler. So this is actually, when we see a measurement stated like that, it's actually implying a possible range rather than an exact length. The error of this measuring device is plus or minus 1/32 of an inch. So what that means is the range that's being implied by this measurement is up to 1/32 smaller and up to 1/32 bigger. So the minimum possible value here would be 2 3/8 minus 1/32 of an inch. And the maximum possible value would be 2 3/8 plus 1/32 of an inch. So now a little bit of review of our fractions. What's our common denominator going to be? 32. So obviously this stays 1/32. What's this going to become? 12. Very good. We're subtracting. So 12 minus 1 is 11/32, and still 2. So 2 11/32 of an inch. Over here, this is still going to be 2 12/32. The difference is we are adding. So 12 plus 1 is 13/32. So 2 13/32 of an inch. So the range that's being implied with this measuring device, with this ruler, because it has a built-in error of plus or minus 1/32 of an inch, when we say something is 2 3/8, it really is anywhere from 2 11/32 to 2 13/32. Let's do this. I'll make it a little bit larger for you. So let's say that something is measured using this device, and it comes to be called 5 5/8 inches. This is what the reported measurement is. I want to find that implied range. So let's go through the steps of finding that implied range. What is the degree of precision here? 1/8. Very good. Where did we get the 1/8? Yeah, I counted 1, 2, 3, 4, 5, 6, 7, 8 divisions between inches, so it's 1/8 of an inch. So what then is my possible error? Plus or minus a 1/16. Where did that come from? Yeah, 1/8 times a half, or divided by 2. So then for my 5 5/8, how do I get my range? Well, 5 5/8 minus 1/16, and 5 5/8 plus 1/16. Of course, this is 10/16. Subtracting will give us 9/16, so 5 9/16. Adding would give us 5 11/16. So our implied range is anywhere from 5 9/16 inches to 5 11/16 inches. A ruler longer. Don't you wish the real world worked like that? If you didn't like it, just adjust the length of an inch. There we go. Okay, so on this measuring device, in your notes, I want you to tell me if something is given a measurement of 4 1/16 inches. What is the implied range? Can't quite fit it all on screen, but we had the steps in that last problem to go through. So for the degree of precision, you get how many divisions are there between 4 and 5 here?
1.
Here's the halfway point. I'd probably even cut it to the 4th point. 1, 2, 3, 4, 5, 6, 7, 8 times 4 is 32. So that is 1/32 of an inch is my degree of precision. So the precision is 1/32. The error, the possible error then is plus or minus 1/64. Good. So for the range, what's the smallest? 4 1/16 minus a 64th would be 1/16 is how many 64ths? 4. Good. So 4 minus 1 is 3 64ths. 4 plus 1 is 5 64ths. How many of you had 4 and 3 64ths up to 4 and 5 64ths? How many of you were getting there? I just cut you short. That's the most common one, is you go straight from the degree of precision and try to do the plus or minus a 32nd. You got to remember to convert it into an error first. You got to divide it by 2. Divide it by 2 or multiply by 1/2. Yep. Yeah, because it's technically it's 1/32 divided by 2, but you got to convert that into a fraction, so that becomes 1/32 times 1/2. I'm thinking you need to try one more of those. I don't know whether to be complimented on this topic or insulted on other ones. Okay, for this one, find if the measurement comes out to be 7 1/4 inches. I know what you're saying. This is actually something that you can relate to. Sure. If the measurement comes out to be 7 1/4 inches, what is that implied range again? Okay, so our degree of precision is 1. Smallest division up here is 1/4 inch, right? So then the error would be plus or minus 1/8. So 7 1/4 minus 1/8 would be, well, 7 1/4 of course is 7 2/8. So minus 1/8 would be 7 1/8 to plus 1/8 would be 7 3/8 to get our possible range. When we're dealing with standard measurement like this, like you said, on a tape measure where it's, you know, quarters, eighths, and so on, we have to know something about the tape measure, because here, you know, saying 7 1/4, well, that could be measured to the nearest 32nd, and it happened to be 8 32nds, which is going to simplify to 1/4. We have to know something about the ruler, the measuring device that's being used, in order to know what the degree of precision in that possible error is. If we don't know the degree of precision, there's not much we can do. We don't have to see the ruler itself. We can be told that the measurement is, you know, 17 1/2 inches, and it's on a ruler that goes to the nearest 16th inch. If that's the case, of course, our degree of precision is 1/16 of an inch. Our possible error is going to be what? 1/16 times 1/2 or divided by 2 is 1/32 of an inch. So that implies that the 17 1/2 inches implies a range How many 30 seconds is 1/2?
30.
Well, 2 times what makes 32? 16, right? So 1 times 16 is 16 30 seconds. So minus 1 would be 17 and 15 30 seconds. To plus 1, 16 plus 1, 17 30 seconds. There you go. Well, because it's from this one. This is the measurement here. Yeah, this is the measurement. 1/2 inch is the 16. So this is minus 1 32nd. And this is the plus 1 32nd. Yeah. Exactly. Yeah.
I was getting confused. I was like, because in the other one I got 7 2/8 and.
Yep. Yeah, 2/8 minus 1/8 would be 1/8, plus 1/8 would be 3/8. You got to go back to the original measurement each time, do the minus 1 and the plus 1. Kind of like when we talked about tolerances. So let's say you measure something, and we're going to use decimals. Now, generally, when we're using decimals, it would be metric. Although for you guys in automotive, it's not uncommon to use decimals in inches because you're dealing with engine bores and stuff like that. So a lot of that comes down to decimals too. But we're going to use metric units a lot of times with our decimals. Here's a common thing that I see. Something measures 32 centimeters. Is there a difference between those two, 32 centimeters and 32.0 centimeters? Well, as far as their numerical value is concerned, 32 and 32.0 are equivalent, they're equal. But when we're talking about measurements, there is a difference. This here, 32 centimeters, implies that this was measured on a device that was capable of measuring to the nearest centimeter. And it happens to be closest to 32. 32.0 implies, and I'm going to do this, I'm going to put it down below here. Again, I apologize for my poor artwork. 32.0 implies that it was measured on a device that was capable of going to the nearest tenth of a centimeter, and it was still closest to 32. So it implies a range of that. Obviously, there's a little bit difference there between that and that. So that 0 on the end implies a change in the degree of precision of our measuring device. This is saying that the last digit here being in the ones place is implying that this measuring device had a degree of precision capable of measuring to the nearest 1 centimeter. This is implying a degree of precision to the tenth of a centimeter. The possible error is still 1/2 or divided by 2. So 1 centimeter divided by 2 is 0.5 centimeters. This is implying an error of plus or minus 1/2 centimeter, 0.5 centimeters. This is implying plus or minus, what's half of 0.1? 0.05. So when you say this, this is implying a range, as we can see here, of 31.5 centimeters, which is just the 32 minus the 0.5, to 32.5 centimeters, which is just the 32 plus the 0.5. Where down here it's implying a range of 32.95, or not 32, 31.95 centimeters to 32.05 centimeters. A lot tighter range. Excuse me. So if we're not given any other information, having that 0 on there tells us that our ruler or measuring device was more precise. So if I report a measurement of 7.36 centimeters, implied in that measurement is a degree of precision of what? But what is the place value of the last digit here? It's the hundredths, 0.01. So it's implying a degree of precision of 0.01 centimeters. What's the implied error? 0.01 divided by 2, or 0.005, 5 thousandths. Very good. So then what is the range implied by that measurement? Oh, 7.36 minus 0.005, or 7.355, up to 7.36 plus 0.005, which would imply 7.365. Make sense? So the degree of precision here is implied when we're dealing with a decimal measurement, is just implied by the place value of the last digit in the measurement. Now this could lead into a discussion of something called significant digits. For this course, we really don't have, it's not part of what you guys need to know. More in depth than we want to go into, but for right now, the biggest thing we want to talk about is that precision and the error in the measurements. And if we were to go on to do a lot of calculations with precise measurements like this, error analysis and stuff like that, that makes a big difference. And I'll show you why. If I were to add if I took two measurements, and let's say I get 12.36, let's say I'm measuring in inches, 12.36 inches, I get another measurement that is 4.752 inches. If I go to add those together, the big problem is, what's the degree of precision of this measurement? Hundredth, right? 0.01. So its possible error is plus or minus 0.005 inches. This error of 5 thousandths of an inch is bigger than the value of this last digit of this measurement. So we can't, when we go to combine those two measurements, we've got a problem. They don't have the same degree of precision. They have different errors. So that's going to interfere with just how we add them. If I were to add these two and get an answer of 17.112, I'm implying that this is now to the nearest thousandth, and it's not, because this first measurement was only the nearest hundredth. So like I said, we're not going to get deep into that conversation, but that's one of the reasons why I want you to be aware of this precision and error in your measurement, because combining these can give us a result. I guess the blunt way to put it is kind of dishonest, because this is implying that this measurement was done to the thousandth of an inch, and one of the inputs, one of the measurements that went into that was only done to the nearest hundredth. So there is an error of 5,000 plus or minus 5 thousandths here that makes this piece of information kind of dishonest or useless, however you want to look at it. So I'm going to give you guys a chance to practice some of this. In your book, on page 173, it's exercise 4.2, problems 1 through 29, the odds. Give you a couple minutes. Kyler, stick around. I'll give you a couple minutes to get started on those, and then Ted May here will take over and do his thing, and we'll see you guys next Tuesday. Everybody got that page down so I can save?